Welcome everybody to this trade and education session. In this session, we have 3 presenters. Each presenter will give a 20-minute presentation, followed by a 10-minute Q&A session. If you have questions, please use the Q&A facility at the bottom of your screen to submit your question. If you are invited to ask a question, we will enable you to unmute your microphone. Please introduce yourself by stating your name and affiliation. Please note that this session will be recorded. Our first presenter will be Steen Westin from the World Trade Organization. Steen, do you want to start sharing your slides?
Yes, sure. Let me share my screen. You should be able to see it in a second. Can you see my screen?
Not really.
Okay, so just a second. Okay.
Okay, now I can see something. Okay, now it works. Great.
There we go.
Thanks a lot. The floor is yours.
Thank you very much. All right. So hello, everybody. Today I'm going to present to you the WTO OECD Balanced Trading Services dataset, the BATIS dataset. It's actually an updated version of an existing dataset. This version was launched this year in January. So I'm going to give you just a little bit of a background because I don't know whether you're knowledgeable in services. But as you may already know, trading services has gained a lot of traction over the past decades or so. And the General Agreements on Trading Services, the GATS, which became effective in 1995, and that was actually at the foundation of the WTO. Since then, there's been a need for more comprehensive information for policymakers, for trade negotiators, for academics, users, you name it. Unfortunately, there has been a lack of data. I would say mainly due to the difficulty of recording services transactions, the lack of knowledge of some of the statistical agencies, or just a lack of resources. So what this data set is trying to do is to fill this gap and to provide users with reliable data. So the BATIS dataset is a complete, consistent, and balanced matrix of trading services. It encompasses both imports and exports for more than 200 economies, broken down by the 12 main services categories in the e-box classifications. The time dimension ranges for 2005 to 2019. And just to give you a quick overview of the presentation, I will just start by giving you a little bit of a background of the data collection, how we fill the gaps to obtain a complete matrix, how we ensured consistency between the different dimensions, how we balance the two flows, and how we present the results and what the results look like. So the first step was to start with an existing dataset, the WTO UNCTAD ITC dataset, which is actually a more aggregated dataset with Partner World that was conducted by some of my colleagues at the WTO. And we use this dataset as boundaries for BATIS. Okay, and what we can see in this dataset is that we do have some asymmetries. So when we look at, for instance, travel and other businesses, we see that they are very well aligned, okay, with minor discrepancies. However, other types of services, such as transport, already show a source of asymmetry, with imports that are systematically higher. This is also the case for financial services and insurance. Okay, so we already know that we have some symmetries. Also, something that is interesting to see, and also something you need to keep in mind, is that there is significant amount of work behind to consolidate all the data sources, merge the data sources and make them comparable. But what we can see from what is bilaterally specified and interesting to see is that there is a significant increase in terms of coverage, because in 2005, when we look at an average of exports and imports, what we can see here is that we had about 32% in value terms that was bilaterally specified, so country to country data with respect to the boundary with partner world. This goes up to 66% in 2018, which is a significant improvement. The picture is a little bit different when we look at, we break it down by sector. It seems that it's more heterogeneous. For instance, manufacturing, maintenance, services, as well as financial services, IP services, business type of services are very well coverage in 2018. That's not the case for all services categories. Okay, so there's still some gaps that remain to be filled. So what we do is we need to develop a methodology to predict those trade flows. And in our methodology, we have different steps. First, what we use is all the information that is available, and particularly what we use is the hierarchy and the structure of the data sets. And we first take into consideration what I call simple derivation. So meaning that if there's any aggregated level that is reported as 0 by any country, then we fairly assume that all the subcategories or sub items will be filled with zeros. There are a number of corrections that were made, for instance, with the negative trade flows that were present in insurance, for instance, were corrected and adjusted. For instance, whenever we had, in fact, we calculated total services accordingly. So there were some adjustments with those corrections. There is also the backcasting forecasting technique. So it's still taking advantage of the available information. And what we use is whenever we have a missing value, either in the middle, beginning, or the end of a time series, we use interpolation, backcasting, forecasting techniques, respectively, using 3-year moving averages of the partner shares in total world trade. Okay, whenever we don't have any information, okay, when the country breakdown is not available, what we use here is a set of regressions. We use gravity models. In fact, what we use is a set of reduced gravity models I'm going to present in a minute. And we use the Poisson pseudo maximum likelihood estimator to solve or to estimate those coefficients. This allows for heteroscedasticity and the presence of 0 trade flows in our data sets. For those who are not familiar with gravity models, just in a few words, the gravity framework implies that the trade flows between 2 countries, okay, are proportional to their economic sizes that are measured by GDP, and inversely proportional to the trade cost between them. For instance, the geographical distance. So what I can do here is I can present to you quickly some results. As you can see here, what we were trying to do is to generate predictions for exports, trade flow. And what would the exercise trying to do is to predict out of sample for countries for which we don't have any information for. So basically, here we have a set of reduced model with the first model that have the full specification, okay? There is no explicit policy type variable in our setting. The reason is because it's usually it comes with an incomplete coverage, and more importantly, it may limit the analytical applications due to endogeneity problems whenever people would like to use those data in other gravity type of settings. The variable selection procedure was done in the first version of this data set, but we also, and to me was an added value to our work, is that we used the cross-validation exercise that was carried out to measure the out-of-sample accuracy of the different specifications of the models, because we have so many models. This is only for exports total services, but we have them by services category. And I'm going to show you the statistical summaries, but there is a significant amount of data entries that are generated with those predictions. But if we look quickly at the results, you may see that there is the ease of access that are represented by distance, contiguity, common language, and colony. There's also what we need to keep in mind here, and that's important to note, is that because a set of fixed effects cannot be used as it is usually done in the literature because of the out-of-sample prediction, instead what we use is the GDP per capita that's actually capture some of the unobservable characteristics of the reporter. And only partner fixed effects are used. In our case, we also have merchandise trade that proved to be an important predictor of the bilateral services flow, and the tourist arrivals that also perform relatively well as a predictor. So if you look at our paper, you will see that there's much more regressions, and you will also see the out-of-sample prediction exercise that was carried out. Just going back quickly, because there's the third step that is also very important. It was the rescaling step, because whenever we use those predictions to predict all missing data, something that was used after that was a rescaling procedure to make sure that the reported values, information, adjusted ones, and the predictions actually sum up in all directions to whatever boundary or total that we have. For this, we use a bi-proportional rescaling or adjustment procedure, the RAS, as they call it, to eliminate the discrepancies between the total services and the main services categories. In particular, we have 3 different groups that were treated differently. And this ensured the internal consistency of our data sets. Just to show you quickly some numbers that are interesting to see after this step, because after this step, we have a complete and consistent matrix of trained services. It's a relatively large data set, I suppose, since it includes more than 60 million entries, out of which you will find that 56% in value terms is actually reported by countries. Okay, this is in total services, and interesting to see that whenever you look at the number of data entries it corresponds to, it's actually only 10%. Okay, which means that we have 90%. Okay, and when you look at the breakdown by services categories, it goes up to 97% of the data sales that are generated. However, we still remain confident in our results, since we do have the upper bound limit, okay, the boundaries that were provided with the initial data set that I first presented. And also because we have more than half of the trade in value terms that actually specified and reported by countries. So I think that was something important to mention. The last step that was carried out was to balance the two flows. And what I mean by that is there are some significant asymmetries between one country report and what its trading partner reports on the other side, on the other flow. So that's what we use to reconcile those values is a weighted average of the reported value and the mirror flow. And first we compute a symmetry index, okay, which measures how much a country agrees on average with its trading partners, okay. The closer you are to one, the closer you agree with your trading partner. And in this step, instead of using a threshold to determine what is acceptable, there is slightly improvement in the methodology that was used in this version of BATIS, is that instead of using this fixed threshold, we used smoothing method that actually limits the unwanted fluctuations in the symmetry index. And this was done over time. And this constitutes an improvement over the previous methodology. At the end of it, what we use is different weights, okay, that are taking into account for the different levels of confidence that we have in our type of data. What I mean by this is reported data will have a strong weight and on the opposite, data that are estimated using back forecasting techniques and generated using gravity models have a lower weight, and we'll have we'll be able to move more whenever we balance the two flows. So there's more adjustment for all the estimates in which we don't have, or for which we have less confidence, let's say. Another thing that is interesting to see is, and as I presented before, at the world level, even though we have small differences, okay, between reported values and balanced values, whenever you look at those, let me reduce this, maybe, there you go. Whenever you have, or those differences maybe can be larger and more significant for individual traders. And this chart shows those differences. It actually shows a ratio between the sum of the balanced values against the reported ones for a set or selection of leading economies. What is interesting to see here is that we have a ratio that is more or less close to one for a lot of countries. If I look at the Netherlands, Brazil, Australia, Japan, it's more or less close to 1, 0.9. However, it seems that for the UK, imports of the United States, and in particularly for Switzerland, it seems that imports are systematically underreported. Okay, so that's a measure as well of how well those countries align with what other countries report.
Sorry to interrupt. You have 3 minutes left.
Yep. Okay, that's fine. I should be on time.
Yeah. Thanks.
Okay. Another feature of BATIS is the possibility to discover trade flows that are actually not visible in raw statistics. And Bermuda is one of them, because when you look at the balance figures, you will see a significant difference between what is reported or adjusted and what is balanced, okay? The results show that imports actually 8 times what are the reported ones on the import side, and almost 50 times in exports. That's also the case for the United States in manufacturing. because the BEA actually do not record those trading partners. More importantly, and what I would like to communicate to you today is how to access the data. You can go to our respective platforms on the OECD and WTO website. You will find the data files, the different codes that are associated with the data, and for your understanding, a paper that explains the methodology and the different steps that were undertaken in this work. You will see that every data entry is flagged with codes showing whether it's reported with an R_estimated or adjusted or modeled. And this is what the table looks like. I just anticipated some of the questions you may ask yourself. And if you ask yourself, should you use reported or balanced values? Well, I would say first that final values, that are the values that are adjusted, are usually the most suitable for most users, wherever the balanced values are considered the best possible quantification of the true trade flows. Should you use those estimates in your gravity setting? Yes, you can. What I would suggest is you can run some robustness check using only reported values, only estimated values, and then including the model estimates, and to see the differences you may get. Finally, and I have 10 seconds left, I would say that we will be more interested in a more granular sectoral breakdown, and as well as adding the mode of supply dimension in the near future, even though it's a challenging task and exercise. So please feel free to reach out should you have any question or feedback. Otherwise, if you have any question, the floor is yours. Thank you very much indeed.
Thanks a lot. That was a great presentation, and I can see this is a great contribution to the literature as well. There was a question by Jose Martin. Can you tell which products are worst reported across industries, such as intellectual properties or something else?
So there are some of the services, or do you want to collect questions, or do you want me to?
I think so far there's only one question in the box, so you probably can answer the question first. If there are more questions pop up, but I can tell you, or I can ask some questions I have in mind.
Yes, of course, absolutely. So obviously there are some services, transactions that are easier to identify and to report or to capture and to collect by statistical agencies. Unlike the goods, services are more particular in the sense that they need different surveys to collect the information. So this is also reflected by the coverage. And this is the reason why I show you this picture, is because if you look at construction, it seems that we have a relatively poor coverage. On the other side, business services show a better coverage. So I would say that, yes, it depends on the services categories. Some services categories that are actually difficult to capture is, I would say, more something. Well, it depends on the resources that countries have as well. So I don't want to generalize, but what I can say also is that my team also help countries, and more particularly least developed countries, to leverage their resources and also to get the knowledge to collect as much information as possible. Yeah, it's a little bit general answer, but it's more less risky answer, I would say.
That's brilliant. I do not see any more questions in the box, so I probably ask one question by myself. So you have been talking about the predictions of the non-reported trade flows, and your primary method is to use gravity models, which kind of assume this linear relationship between the variables. Have you consider the nonlinear techniques like machine learning method maybe a little bit more precise in terms of predicting the trade flows. The question is, you have been talking about out of sample prediction errors, but it's not totally clear from the table here. Is there more accurate method that you can apply, to get like better picture of what the trade flows that are missing?
Yeah. Okay. So basically, what we have here is in what we usually have in trade is whenever you want to predict bilateral trade flows, is you have a zero inflated process. Okay, you have an excess of zeros in your data set. So there are a series of techniques that you cannot use. You cannot. So there are some workarounds that you can see in the literature. You can have you can remove those zeros. You can use log ordinary least squares. You can have you have different methods. But the reason why we use the PPML, the Poisson pseudo maximum likelihood, is because it allows for this nonlinear relationship. Okay, we actually tested other inflated zero processes, such as the ZIP, the zero inflated process, and the negative binomial and inflated. Those exist and are usable, but we tested that back in the day, and we found that PPML actually gives better results. The reason why we used out-of-sample predictions, and I think that's an added value because I've never seen that in the trade literature, is that in terms of R squared and the accuracy measures, as well as the inference that is usually provided with this theoretical setting, I would say that it does not fit entirely our purpose, because what we want in the end of the day is to have the best possible predictions. So what we did instead, or on top of this, is to use different variables, okay, different settings. We use an out-of-sample prediction, which are basically simulations. And the principle is that you take a sample, a similar sample between the different specifications, okay? You will split, and this, I believe, comes from more the machine learning side, even though that is used in statistics. You have basically one sample that you will split between a test set and a training set. So it's often referred to as cross-validation, because you will validate. So you will first estimate the set of coefficients using the training set. Let's say that you split 30% in the test set and 70% in the training set. You estimate the coefficients with the training set, then you try to predict the remaining test sets. Then you measure the difference you have in the predictions with the raw values, the original values. Then you measure criteria of error criteria, let's say mean absolute error. You store it and you repeat this process. So you shuffle your data sets, you split it, you estimate it, you compute the error you make. This will give you a sense of the accuracy that you have with your model. You repeat it 200 times, 1,000 times, and then you will see the distribution of the error. And then it will give you a better idea of how well your model performs out of sample.
Okay, brilliant. So I think we're almost on time. Let's probably move to the next paper. Our next paper will be presented by Sarah Zeller and Reese Humphreys from the Office for National Statistics. Probably you want to stop sharing, and then Sarah or Reese, whoever want to present first, you can start sharing your screen.
Thank you. Yes, Reese, if you can start to share the presentation, we can start. I think it's coming. I cannot see it yet, but okay, here we go. Yes.
Great, I can see it.
Thank you.
Perfect.
Okay. Yeah. Thank you for the invitation. This conference is fantastic for us to be here. We want to present our work on quality adjustment in education, and particularly focusing on the role of well-being and bullying. And just to give a general outline of our presentation, I will start describing the main concept of public service productivity, explaining what public service productivity is, but also mentioning some difficulties that we have in analyzing this service area, which have been already discussed in other sessions at this conference. And this will lead to the definition of quality adjustment, also the new methods that we have implemented on the quality adjustment, in particular education. So as the title highlighted, this presentation will focus on education. Before starting with the presentation, I want just to highlight that quality adjustment is measures and an adjustment that we include only in public service productivity. We don't use a quality adjustment for other measures of ONS, for example, in the national account. And in describing public service productivity, we could say that in public service productivity, we include all the services delivered by or paid for the public sector. As you can see from this slide, productivity is the measure of output and inputs, and is calculated by divided total output by total inputs. Inputs comprise volume estimates of labor, capital, intermediate consumption. And instead, we use a quantity to describe our output. And when the data are relevant and are available, we measure our output also with the quality measures. For most of the service areas, output is measured in direct volume terms by the number of activities performed by that service areas. And then the activities are weighting together into a cost weight activity index. For example, if we think about healthcare section, we can say that we have a number of HIP operation, for example, number of GP visits and other NHS services. That all together can be weighted using their unit cost, and at the end we will create the volume index for all the healthcare services. Focusing a little more on the definition of quality adjustment, we could say that quality adjustment is one of the main recommendations in the Atkinson review, as you can see from this slide. And to understand the quality adjustment, we need to think about the characteristic of the public sector. Indeed, for a normal market good, an increase in price usually reflect an improvement in quality, but in public service we don't have a market price, and for this reason we cannot use prices to assess the changes. And it's true that we are using costs, which usually higher cost services are a sign of a greater value instead of lower cost services at the opposite. Give the opposite information, but we think that using only services may not differentiate enough between high and low value services. And for this reason, we look to identify, together with direct measure of output, also the quality measures. And this will help to understand the impact on the successful outcomes. In other words, quality adjustment allows to link better the output to the final outcomes. Working on quality adjustment is not an easy exercise, and we follow a specific approach when we create a new quality adjustment. But in this slide and for this presentation, we summarize what we think that there are three main aspects. The first one is the use of multiple indicators. Indeed, we think that we could have a very good single indicator for quality adjustment, but often it is not enough to represent completely the quality of the services. And thinking about education, Risa will explain more in details later what we are doing for education quality adjustment. But just as an example, we currently use the attainment data. And we think the attainment data for quality adjustment in education is a very robust option. But we still think that combining this data with other indicators of quality adjustment will help to understand even more this service and to give a more holistic idea of what this service is. Another aspect that we really highlight and we think is very important is meeting the stakeholders and to discuss with them about the characteristic of the service, but also regarding their need. For example, again, thinking about education, for us it's very important to discuss with the Department for Education or the educational charities, think tanks, to understand exactly what they are interested in and what they would consider useful. And another aspect which is listed in this slide and we think that is crucial is that the quality adjustment should be monitored over time. This is really highlighted also in the access review. And for this reason, we need to review constantly our data sources and our method to ensure that our estimates remain of a high level quality and always updated. In public service productivity, until now, we quality adjusted about 50% of the total public service productivity. If the question is, does the quality adjustment make a difference? The answer is that based on the statistic that we produce, we could say that creating and implementing a quality adjustment has helped to understand better the public service productivity. In general, we could say that without a quality adjustment, we would see a decrease in productivity over 20 years. Instead of including quality adjustment in our statistic, we can see an improvement of the index over this period. And now we can focus a little more on the core of this presentation, which is education. In education, we could say that this is the second largest area in public service productivity after healthcare, and it accounts for about 18% of public service output in our last estimates of 2018. And think about only the quantity output, this consists of the number of students in education, which are from preschool until further education, and they are adjusted for attendance rate. We think that this is a very clear activity measure that we are using for our output, the quantity part of output, where we think that using only this measure would create two different scenarios. Indeed, if the pupils, the numbers of pupils in school increase, the education system will look more productive, assuming, of course, that inputs remain the same. But if pupils are now leaving school with fewer or worse qualification, then schools are actually producing less. And we suggest that this scenario wouldn't represent completely the purpose of the education service. And for this reason, we suggest that we need more suitable quality adjustment measures. In the last years, different exercises have been done on quality adjustment, and until the last publication of last month, we included attainment of secondary school, and we measure it based on GCS or equivalent levels. This measure was introduced in 3 steps. And in the last step, that, as I mentioned before, we published last month, we use what is called the cohort split in order to attribute the contribution to attainment over the previous 11 years of education. For example, GCSE attainment data published for the academic year 2017-2018 reflects the effectiveness of the teaching from year 2 to year 11. We are aware that using only attainment could link to a risk and capture a great inflation. And as you can see from this slide in particular shows the proportion of students get different grades over time. As you can see, A stars and A proportion have increased almost double in the time period. This is for sure one aspect that we need to understand better, also take better under control in our developing methods. But if you could switch to the next slide, please. The quality adjustment in education, as you can see from this graph, has made a difference in our statistic. And as you can see, the orange line highlighted the inclusion on the quality adjustment instead of the blue line exclude the quality adjustment in our statistic. And as a result, the quality adjusted series is smoother than previously. But as I also mentioned before, measuring quality in education is a tricky process and it creates quite a few challenges. First of all, it would be important to continue to work on quality adjustment indicators and also to consider other indicators. However, we always have to think and be aware that we will face different challenges. One regards data completeness. For example, so in the past, we tried to take into consideration other source of data, for example, pattern of offset, but we weren't able to use properly this data because they didn't cover completely the period that we wanted to cover at the annual perspective as we use our current sources. The second aspect, and I'm going a little fast in describing this aspect, but probably during the discussion QA, we can explain them a little better. The second aspect regards attributability. For example, we could consider children's well-being in education services as a quality adjustment, but we have really to think if children well-being is attributable by school. And the third aspect that we definitely need to consider is the problem of endogeneity. We know that it is quite a big problem. We discussed those in the past with different colleagues, and each measure that we include in quality adjustment for education might bring the risk of endogeneity. We think that a more sophisticated model and also the introduction of other variables might help to disentangle a little better this effect and to express better even the future of our statistic. In terms of other variables that we can use on quality adjustment, we are currently doing the public service productivity additional research, and we aim to discuss more and more also with our users and stakeholders on it. But one aspect that we can probably take into consideration in the future is the teacher quality. We can now focus a little more on the definition of bullying and well-being. What is well-being? There are different definitions of well-being, and the ones that are presented in this slide are the most common definition. In general, we can say that the bullying has a power over the victim, and the victim, as a result, has difficulties in responding to the bullying. It's important to think about bullying for, of course, a different reason. One of the main reasons is that the effect of bullying are really can be seen really over time, and it could be they could have both immediate effect but also long-term effect, and could bring poor school achievement but also depression in adult and so on. And in the last two slides, I think we report pretty clearly that the educational services are really aware about this problem, and they propose and publish several documents in the last years regarding how to tackle bullying in schools, and this happened both in England and in the other countries in the UK. And these are the law that has been published in the last years on bullying. And Rhys, if you want to take from the next slide.
Yes, thank you, Sarah. Great. So I'll now through the data and methodology behind our introduction of bullying and well-being data into our measure of quality in education. The data we use comes from both the British Household Panel Survey and its successor survey, Understanding Society. These are large-scale longitudinal surveys that cover the entirety of the UK and give us annual data for the whole time period that we are concerned with, which is between 1997 and 2018. This is very important for us as we are mainly concerned with producing annual estimates of productivity. Importantly, both surveys also contain youth questionnaires. These are to be completed by members of the survey's households between the ages of 10 and 15. And this questionnaire contains relevant questions related to bullying at school and life satisfaction and other measures of happiness with different aspects of their life. The specific questions that we are interested in and that we based our analysis on are as follows. The main data comes from the bullying at school questions. The British Household Panel Survey includes a question asking children how much they worried about being bullied at school, whilst the Understanding Society survey asked more directly how often children are physically bullied or bullied in other ways at school. In both cases then, we've grouped the proportion of children who've responded that they have experienced some bullying and grouped the respondents who said they experienced no bullying at all. The other data we were interested in was life satisfaction, and we used these groupings to determine kind of the mean life satisfaction of children who reported at least some bullying at school and the mean life satisfaction of children who reported no bullying at all. The summary data this gives us are as follows. You can see that the prevalence of bullying in schools has been fairly constant over the entire time period, barring one drop in the earliest time period, while the mean life satisfaction of students also provides a kind of a constant relationship with the exception of one time period. It should be noted that the higher the mean life satisfaction in the data actually means a lower life satisfaction. As you can see, there's a fairly constant relationship and maybe a possible increase in the most recent periods of the disparity in life satisfaction of bullied and non-bullied students. We use this data to create an index of bullying at school. So we use the mean life satisfaction as some sort of simple severity rate of bullying, such that the students who do report bullying receive an education of quality LS less. So an education of LS quality compared to non-bullied students. This then gives us a fairly constant index. It doesn't really vary around the 100 mark at all. It should be noted that a higher growth in the index represents either the severity of bullying or the prevalence of bullying being reduced. And as you can see, there's not much movement across the series. As Sarah previously mentioned, the basis of public service productivity estimates comes from a review of these statistics by Sir Tony Atkinson. As part of a guideline set out in that review, it suggested that quality indices and quantity indices be aggregated on a one-to-one basis. This means that when deriving a quality index, the various measures of quality must be weighted together. If the data were available, we would like to use the percentage of school budget used on either anti-bullying or safeguarding measures. But in lieu of that data, we have used the aforementioned Education Inspections Act 2006, which is one of the main pieces of anti-bullying education brought in by the British government in the past 50 years, as a price signal by government signalling their intent of cracking down on bullying. This can be seen, from 2006 onwards, we increase kind of a weighting of bullying within our quality index. Nevertheless, we keep bullying at a low weighting within this quality index, both to reflect the importance of exam results for schools, and also to account somewhat for the inherent endogeneity present by including bullying statistics, as we understand that bullying does have an impact on attainment itself, and we wouldn't want to double count too much. This slide shows the impact of including a bullying adjustment. Sorry?
Sorry to interrupt. You have 2 minutes left. Could you quickly ramp up?
Thank you.
Sorry.
That's fine. We're nearly finished. So this slide shows the impact of including bullying data into our measure of quality. It's a simple reduction in quality, but we view this as capturing the loss of quality that has always been present by the existence of bullying at schools. So we're just rectifying an overestimation of quality previously. And in summary, really, the intention behind including bullying in our quality adjustment is to widen our definition of quality in the educational services away from being a pure measure of exam attainment. The reduction of bullying in schools as an explicit measure of quality in and of itself. And this is especially important given schools' legal requirement to address this. But as Sarah alluded to earlier, public service productivity and non-market output more broadly are areas which are particularly difficult to measure and are areas of ongoing work and development. Thank you very much. Here are our emails. This is a piece of work which we are continuously developing, so all contributions are welcomed. And open up the floor to questions if there are any.
Great, perfect, on time. Currently I do not see any questions in box. Probably I have one question in terms of endogeneity. Talk a little bit about endogeneity during your presentation. If I think about this quality and also the bullying and also the other measures might be somehow correlated and somehow endogenous. Do you want to talk a little bit more on how to deal with the endogeneity? And there is a second question coming up saying, what factors impact bullying at the school? Do you have geographical information about that? Have you tried to look at cities that require additional measures or monitoring?
I can take maybe I could start for the second question, which is maybe quicker to answer. So regarding bullying, we have information, as Rhys mentioned, from Understanding Society and the British Household Panel. So we are able to follow the individuals because there are both of them longitudinal survey over time. Unfortunately, we didn't look and we don't have a specific regional information or even information on cities with this data. I agree that it would be very interesting to have more granularity on it. And also for this reason, we are in contact with different stakeholders and try to understand a little more about bullying and also to understand if it's possible to have more granularity information on this measure. However, the important things of the data that we have, which is crucial for our statistic in public services, that these data are representative for the entire UK. So we don't cover only England, but we are really able to include also all the other countries in the UK. And for this reason, we think that also these data are very robust, together with all the other characteristics that, let's say that there are included in this data as well. And this is also the reason that we are able to have the information from the first years that we want to analyze, which in our case is 1997. And probably I need also to specify that, as you see in our graph, the years that we are taking in consideration is 2018, because in public service productivity we publish data with 2 years lag. And the reason why is because we are trying to improve our statistic, and in 2 years lag we have more robust information and better data to analyze also the quality adjustment. However, every quarter we also publish our statistic, so we have more experimental estimates, but what we are talking here is our annual statistic. And the second question on endogeneity, I think that endogeneity, in particular for education service, is quite a big issue, because it's really difficult to disentangle the different effects. So attainment has quite also strong correlation with the many other aspects. Bullying can be one of these one. The quality of the teacher can be another one. So it's an aspect that in the service like education, I think is pretty big, and I think that a more sophisticated model should be implemented to disentangle much more this aspect. We don't have a answer at this moment of which would be the magic recipe to do it, but again, it's very important for us to understand which are the availability on the data, both in England and the other countries, as well as which is the point of view of the experts on education, who could also guide us in understanding a little better which is this complex service area, how we can disentangle all the correlations that we find there.
Great, thanks. I think we have 3 minutes for another question. If anyone have a question, please feel free to post it into the Q&A box. Okay, so probably I have this question about, like, for your exact construction measures, you have different ways. Do you mind to talk a little bit again how you actually weight, like how this weight constructed? I might have missed that particular part. So you said, like, so in the last few slides, when you talk about the exact construction with the quality measures, so you have the weight for bullying, you have the weight for the attainment. I think I might have just missed.
Is it this slide?
Yes, exactly. How exactly the weight is, because the weight somehow could be endogenous or could be exogenous. So it's just I think I just missed that part. Sorry.
It's fairly simplistic. It's we have a index for the growth of attainment year on year, and an index for the change in bullying year on year. We apply a weighting to the growth rates of both these indices.
So my key question is this weight changing over time, or is it fixed?
It's fixed between two time periods. So it's at 5% and at 10% following 2006.
I see. Okay. You fix it.
Difficulty is, but it's for lack of data, really.
I see.
We would like to have, I don't know, more accurate price data that we could use, so that we could give a price to bullying measures in schools and more mainstream just for teaching at schools, but this isn't available at this time.
I see. But the fact that you fix the weights probably helped you to answer this internality question is because it's fixed ex ante. So it's not that indulgent. Okay, so I think we're perfectly on time. Let's move to my paper. Let me try to see if I can share my screen. Okay, thanks a lot for including the paper in the program. Today, I will be presenting the value of deep trade agreement in the presence of pricing to market. This is joint work with Meredith Crowley and Thomas Pryor at the University of Cambridge. So this work is still a little bit preliminary, so any comments are extremely welcome. So how firms respond to trade policy changes has important implications for market competitiveness and warfare. So the estimates of firms' pricing and export decisions are the key for calibrating structural trade models, as well as understanding the global impacts of the trade liberalizations. Existing studies have documented extensive evidence on how firms adjust their prices and trade volumes in response to policy changes. And this paper typically take two approaches. One look at the firms from multiple origins selling to a particular destination, and another group of literature looks at firms responsive to a particular policy change from a particular origin to multiple destinations. However, if you think about this, we're kind of missing some critical part here. It's actually specifically the indirect effects of trade policy changes on third countries are often overlooked by just looking at this multi to single destinations or multi or a single origin to multiple destinations. Therefore, to properly account for the indirect effects of trade policy changes on third countries, we might want to exploit the data of firms from both multiple origins to multiple destinations. So in this paper, using the product export data from 640,000 firms located in 13 emerging and low income countries, selling to 165 destinations, we examined the direct and indirect impacts of preferential trade agreements and tariffs on firms exporting decisions, such as their decisions on trade values, markups, and entry-exit decisions. In doing so, we developed a new empirical measure that captures the competitive pressure created by the destination country and the origin's competitors, and we document a significant third country impacts of the PTAs and tariffs. Finally, we exploit the newly constructed deep trade agreement database from the World Bank and document evidence on the detailed individual provisions, the effects of detailed individual provisions on firms' exporting behavior. In this presentation, I will only highlight the results from the competition policy provisions, but in our paper, we provide a wide range of different provision results, such as the effects of the rules of origin or the mutual recognition that is really hot in the debate. Okay, so this slide summarizes our key findings. So first of all, we found no direct impacts of PTAs on firms' export values. This might be a little bit surprising, but if you think about most countries in our dataset are those middle, like low-income developing countries. And when they sign the PTA, they probably focus more on the tariff liberalization rather than the reductions in the non-tariff barriers. But we do find a significant pro-competitive effects of the PTAs because we see the markup drops. So the markup from the origin country to the destination drops by about 4% if the origin and destination sign a PTA. We also find this PTA encourage entry for the firms from the origin to the destination country. Now turning to the tariff results, we find a 1% bilateral tariff drop is associated with increase in the export values from the firms from the origin country to the destination country by 1.3%. And we found similar results as in the PTAs. We found the preferential tariffs are pro-competitive as it reduces markups and encourage entry. Our key contribution here is to estimate the third country competition effects for the PTAs and tariffs. If 10% of the country's competitors have a PTA with a destination, the export value from the origin country dropped by 2.5%. But also we found a pro-competitive effects of the third country competition effects. So essentially we find the markup drop by 0.5% if 10% of the origin country competitors have a PTA with a destination. It's encouraged entry as we just found in the direct effects. But in contrast, when we look at the third country competition effects of tariffs, we find there's huge drop in the trade values, but there's no significant change in markup, and it leads small firms from the origin market, from the origin country to exit the market. So it seems this third country competition effects of the tariffs is demonstrates strong trade deflection effects. So altogether, we find significant indirect effects of the PTAs and tariffs on the through this third country competition channel. Very briefly on the literature, we contribute the gravity literature by including and calculating the third country competition effects, and we directly estimate the markup elasticities in response to trade policy changes, and we contribute this literature on third country trade policy spillovers by constructing new measures and document new facts. Now turning to our data, we have a really big data set here. So combining the data from the importing exporting database from the World Bank with the transactional level data from China and Egypt, we build an unbalanced panel of 27.5 million firm product origin destination year observations. So this map highlights the countries in our data set, and it's also showing in the table below here. Although the data availability differs across countries, 90% of our data come from the year from 2000 to 2009. Also, for each of these origin countries, we have measures for the PTAs and also the preferential tariff for 165 destinations. And for all the trade partners of these 165 destinations, we construct the competitors measures. Just to give you an idea about this data set and the trade agreements in our in our sample, if you think about the observations associated to Albania, so 11% of the observations associated with Albania are to the destinations that have a PTA with Albania, but 3/4 of these observations are to the destination that at least one of Albania's competitors have a PTA with the destination. Where if we look at Mexico, 60% of the observations are to destinations that have a PTA with Mexico, but nearly 80% of the observations are to the destinations where at least one of Mexico's competitors have a PTA with the destination. Okay, now turning to our estimation strategy, we start with a very simple model by directly regressing the trade values, the unit prices, and the market share of the firms on the preferential trade agreements with a set of fixed effects. So the dependent variable here is trade value or the unit price or the market share of a particular firm in one of our 13 origin countries to one of these 165 destinations at the product level at annual frequency. So we regress the log of this variable on the PTA dummies. Importantly, we include the firm origin product year fixed effects, which controls all the confounding factors at the firm level that are not destination specific. Importantly, it captures the marginal cost of the firm. So whenever we regress the prices on the PTAs, we are actually capturing the markup effects because the marginal cost changes are controlled by the fixed effects. We also include the destination product year fixed effects to control for the changes in the destination specific demand. And we also include the origin destination fixed effect to control for the factors that time invariant influencing the bilateral trade flow, such as distance, language, all these different gravity variables. Our key innovation here is to introduce a measure that captures the third country competition effects. Specifically, we calculate the share of country O's competitors that have a PTA with the destination at the product level for each time period. So this figure shows you the construction of this measure. So in the very bottom of this figure, we have the origin country here, and it is exporting to this red circle, which is the destination. As you can see from the figure, we have five different other countries also exporting to the destination. And the first three countries have a PTA with the destination, and the last two countries do not. And these numbers or these pieces in the circle indicate the share between the destination and the exporting country. So what we do here is we construct the product level import weighted share of competitors' countries that have a PTA with the destination. In this particular case, we multiply this number, the trade share, by 1 if the country have a PTA with the destination, and we multiply this number, the trade share, by 0 if it does not. And we ended up with 60% of these competitors have a PTA, as you can see from the graph. Of course, practically, this is more complicated. In fact, we use the country data from 250 countries to construct this single measure for each of the bilateral pairs and at the product level, and also for each of the time periods available in our data set. This is really computational intensive, and using a multi-core computational server running code in parallel, it took several days to just construct this single measure here. Now, once we have constructed the measure, we're going to extend the specification, also includes the bilateral tariffs, and construct the third country competitors effects for tariffs, just the way we did for the PTAs. And also we're going to include specific information about provisions underlying the PTAs, and also construct the competitor provision effects. Okay, so this table shows you the impacts of the PTAs and tariffs on the actual values of the firms from the origin. As you can see from the first row here, there's no substantial effect on the bilateral trade flows. So, but we do find a significant impact of these competitors' PTAs on the bilateral trade flows. So if 10% of origins competitors in a destination have a PTA, then the average export from the origin going to drop by 2.5%. Similarly, we find very significant effects for the tariffs and the competitor tariffs. For a 1% increase in the bilateral tariff in the destination, the average export from the origin dropped by 1.3%. And in contrast, for 1% increase in the average tariff against the competitors in a destination, the average exports from the origin going to increase. This is essentially because if your competitors charge higher prices, then the consumer is going to buy more from you rather than your competitors. Okay, but now if we look at markups, we find both the PTAs and the competitor PTAs reduce markups, showing a significant pro-competitive effect. So if the origin and the destination have a PTA, the average markup from the origin dropped by 3%. And if 10% of origin competitors in destination have a PTA, then we find the average markup from the origin drops by 0.5%. We also find very significant effects on tariffs. As you can see from the table, the average markup increases in bilateral tariff, but we do not find a significant effect for the competitors' tariffs. Now, if you think about this result for a second, you may notice some of these results are a little bit counterintuitive. For example, you may expect the competitors' PTA effects to have a positive sign and to have the opposite effect of the bilateral or the direct effects of PTA. Also, for those of you who are familiar with at least the trade literature, you may expect markups to decrease rather than increase as the bilateral tariffs goes up. Essentially, you may think the firm want to absorb some of the tariff changes by reducing their markups to avoid very big drop in demand. While both intuitions are correct, these simple intuitions miss critical part of the problem. For example, this argument is not correct because not completely true because lots of PTAs and lots of provisions in the PTAs have effects not only for those countries that is directly participating in the trade agreement, but also those non-participating countries. So a typical example of this is a competition policy regulating the market. It will affect those countries that are involved in the PTA, but also in those countries that haven't been involved in the PTA. So therefore, in these cases, you will expect to have the same sign or same effects for both the PTAs and the competitors' PTAs. Regarding to the results for the tariffs, this argument actually ignores the extensive margin adjustments. So if you think about this, so higher tariffs may lead small firms to exit, and then this average markup will probably go up. And this is because those bigger firms that having the market power tend to charge much higher markups compared to those relatively smaller firms. So the exits of the smaller firms going to push up the markup distribution and making the average markup to go up. Now, finally, if we go to the extensive margin results, we find exactly this is the case. So because we have a very big data set, we cannot really do the conventional estimation strategy like PPML or like just do the extensive margin adjustment estimation, because otherwise, because it would create billions of observations just for this single estimation. This is currently beyond our estimation capacity. So what we're going to do here is we're going to use this market share measure to infer the extensive margin adjustment indirectly. To give you an example here, so we're going to construct this measure among all firms from the origin. So suppose there are two firms of a same size from the origin that are selling to the destination country. This market share will be calculated as 50% each. Now consider case if a new firm of a similar size from the origin country enters the destination, this market share will be 1/3 each. So because there are three firms from the origin that are selling to the destination. But you notice like as more firms enter the market share actually goes down, and as more firms exiting the market, the average market share will actually go up. So now if we look at this table, it gives you the results. So the indirect evidence of extensive margin adjustment in response to the PTA and tariffs. We find the average market share among all the firms from the origin drops if the origin and destination have a PTA, suggesting lots of small firms from the origin are entering the destination market. We find very similar results for the competitors' PTAs. These are all pro-competitive. And we find a significant result also for the competitors' tariffs. What's really interesting here is we find the average market share to increase along with bilateral tariffs. This suggests probably some small firms from the origin country are exiting the destination market because of higher tariffs, because their products become more expensive and more difficult to sell in the destination. And this probably explains the increase of the average markups we just observed from previous slide. Okay, so far I have been talking about the general effects of the PTAs, but in practice, the effects of the PTAs can differ substantially depending on the underlying provisions, the details of these preferential trade agreements. So what we're going to show here is we're going to show you the results for two competition policy provisions on the effects on the firm's trade values. In the paper, we discuss a wide range of different provisions. So what these two competition provisions are capturing? So the first one captures whether the trade agreement prohibits or regulates cartels or concerned practices, whereas the second one captures whether this trade agreement prohibits or regulates the abuse of market dominance. So what we're going to do here is we're going to collect answers to these two questions and make them into dummy variables, and we're going to construct the competitors measures just the way we did for the PTAs. This table shows the estimation results. The upper panel shows you the direct impact of the two provisions on trade values and quantity. And the bottom panel shows you the indirect effects of the competitors' PTA changes on the trade values and quantity. As you can see from the table, both provisions promote competition and boost trade flows. However, what's very interesting here is these competitor effects of the provisions go to the same direction as their own bilateral effects because these provisions influence the market condition in general. Okay, to quickly sum up, using firm product level data from 13 developing countries to 165 destinations, we examined the direct and indirect third country effects of PTAs and preferential tariffs. We found that PTAs and tariff reductions are in general pro-competitive as they reduce markups and encourage entry. However, the drops in tariffs between the origin's competitors and the destination can have significant trade deflection effects, causing small firms from the origin to exit and causing the bilateral trade flows to drop. In contrast, the direction of the competitors' effects of PTAs depends on the underlying provisions of these PTAs. So you notice both the origin and third countries can benefit from the provisions if this provision improves the general market environment, such as these competition policies regulating the cartels or the competition policies preventing the market dominance. Altogether, I think our paper shows the importance of constructing the multi-country firm-level panel datasets and their associated measures in uncovering the full impacts of trade policy changes. I will stop here. Thank you very much. Happy to take any questions. Should I stop share? Let me stop sharing the. I do not see any questions in the Q&A box. Okay, if there's no question for my paper, if you have any questions for the previous two papers, please also feel free to post it in the Q&A box and we can discuss as well. Okay, if let's wait for 1 minute. If there's no more questions, we can conclude the session. Okay, let's stop here. Thanks a lot for all the great talks, and thanks a lot for participating in this session. If you have any more questions or if you want to discuss, please feel free to email the presenters. This concludes our session. Thank you very much.